This unit is going to focus on transformations. So we're going to be looking at transformations of shapes in the coordinate plane. You studied this back in middle school, so it's been a little while since you've seen this, but it shouldn't be a totally new concept for you. We'll be reviewing some vocabulary and then also looking at 4 different types of transformations in this unit. So quickly, we're just going to review the different types of transformations that can occur. So if we look at this first picture in example 1, we want to think about what types of movements would have caused that shape to move and land in where that one in the dashed lines would be. So if I had shifted that picture to the right and then down, then we would have completed a translation. So a translation is just sliding that image up, down, or left and right. The next picture, this picture has been flipped. Okay, so we flipped it across that y-axis. And when we flip that across the axis, we call that a reflection. So there are other types of reflections. We're going to look at several different ones when we get to that particular type. So we can flip across the y-axis, the x-axis. We can flip across actually any line in the coordinate plane. In this third example, what I like to think about with this type of transformation is that I'm just taking and sliding that around. It's like if I put my hand right on top of that triangle and rotated it around to the left, then it would land in that other quadrant. And so that would be the result of a rotation. And then in this last one here actually is another example of a reflection, but this one was reflected across the x-axis. So reflections, rotations, and translations are all rigid transformations, meaning that the result at the end is the same shape. It hasn't changed size. And so we have some congruence with those shapes. Complete the statement using the description of the translation of 2 vertices of a triangle at 2, 0 and 3, 4. If 2, 0 translates to 4, 1, then 3, 4 translates to blank. So the first thing that we have to think about here is the rule and what change happened to get this shape to move. So first we're going to look at the x values of those ordered pairs. So we went from 2 on the x-axis to 4 on the x-axis. And so to go from 2 to 4, we're going to add 2. So to write the rule, we're going to say that we're going to take our x value and add 2. We also have to do the same thing for the y value. So we would look at the y value of each of those. So we are going from 0 to 1, which is a plus 1. So we're going to take our y value and add 1. So we use that rule to help us with the point at 3, 4. We're going to plug in 3 for x and 4 for y. So we would say 3 plus 2, 4 plus 1 means that our new point is going to plot at 5, 5 after that translation. If 2, 0 translates to -2, -1, then 3, 4 is going to translate to what? So again, to go from 2 to negative 2 actually means we're going to be going to the left if we think about on a number line. So we would be subtracting 4. So we would say x minus 4. If we start at 0 and go to negative 1, I didn't mean to put a parenthesis there, that needs to be a comma. If we start at 0 and go to negative 1, again we're subtracting, so we would say y minus, and then we would go to the left 1 unit to get to negative 1. So again, we come over here to 3, 4, so we plug in our x and y, so 3 minus 4, and then 4 minus 1 means that our final order pair is going to put us at negative 1, 3. And that would be the point after we applied the rule for the transformation. For example 3, we have some new vocabulary. So we say the point on an image. So the image is the result of a transformation or multiple transformations in some cases. And we want to find the corresponding point on the pre-image. So the pre-image is where we started before the transformation occurred. So in this example, we're actually going to be working backwards. So we started with the point, we're starting with the point 2, negative 4, which is the image. So this, we subtracted 4 from some number to get to 2. So we can actually kind of think about that and set that up like it's an algebra problem. We'd say x minus 4 equals 2. I add 4 to both sides, so x would be equal to 6. So if I started at 6 and moved to the left 4 units, that's what the minus tells me, then I would end up at the point 2. We do the same thing with y plus 3. So the point y plus 3, and I ended up at negative 4, so we would subtract 3 from both sides, which means that that point started at 6, negative 7. We'll draw a line there so we know that's where that one came from. And then for the second example, we can do the same thing. So we're ending at the point negative 5, negative 7. The transformation that occurred, so the xy is the original point, we arrow, that means the transformation occurred, and then we flipped the negative y. So this is actually some notation for a reflection. So the x value doesn't change. So if it was at negative 5 before, it's going to be at negative 5 because that's what that tells me in that mapping notation. Now, we would say that the sign, we took the opposite sign to get to negative 7. So if I landed on negative 7, that means I have to work backwards. So we would say that the opposite of y is equal to the opposite of 7. I don't want this to be negative, so we would divide both sides by negative 1, which would make that positive. So again, we're going to talk more about the vocabulary, more about those mapping functions and how to read some of that notation. After you watch this video, you also need to look through the PowerPoint or the slides presentation on this page that has some additional information about translations.